All right, let's talk about one of the most exciting frontiers in AI right now, models that can actually see. We're diving deep into vision language models, the tech that's finally connecting the dots between sight and language. And for us developers, well, this changes just about everything. So think about the core problem for a second. How do you actually teach a machine to look at a picture and see, well, more than just pixels? How do you get it to understand what's happening, to reason about it, and then explain it all back in normal human language? That is the fundamental challenge that vision language models, or VLMs, are built to crack. And the incredible thing is, it's working. This isn't just another small step forward, it's a genuine paradigm shift. And what that means for you as a developer is that a whole new universe of applications just opened up. So in this explainer, we're going to break down how these things tick, and more importantly, how you can start using them in your own work. So here's our game plan. We'll kick things off with what these models are and what they can actually do. Then we'll get into the secret sauce, pre-training. After that, we'll pop the hood and look at their anatomy. And then, the really important part, the toolkit you can use to customize them. And finally, we'll take a peek at what's coming next. Okay, first up, AI that sees and speaks. Let's get crystal clear on what we're actually talking about when we say vision language models. At their heart, VLMs are basically translators between the world of sight and the world of text. But we're talking way beyond just slapping a label on a photo. These models can interpret the context of a scene, they can reason about the relationships between objects, and they can even generate brand new data that mixes images and language together. And that leads to some absolutely wild capabilities. I mean, we're talking about generating a photorealistic image just by describing it, or telling a robot what to do using plain English. These models can watch a video and tell you exactly what happened, or answer really tricky questions about an image that require genuine common sense reasoning. The big one for developers? You can build systems that can spot pretty much any object you can think of, right out of the box. So how in the world do they get this smart? Well, that brings us to the real magic ingredient, the secret sauce behind all of this power, this idea of massive, large-scale pre-training. The whole game changed with pre-training. The basic idea is you take a ridiculously large model and you just feed it a huge chunk of the internet. Tons and tons of images and the text that goes with them. You're not training it on one specific little task. Nope. You're training it on a general task, just to learn the connections between images and words. This process is what bakes a massive foundation of world knowledge right into the model itself. And this quote right here, it just nails it. It really is all about the scale. It's not just about having a big model, and it's not just about having a lot of data. It's the combination of the two. We're talking billions of parameters learning from an ocean of data that lets these models build such a deep and flexible understanding of our world. Okay, so we get what they are and we get why they're so powerful. So now let's pop the hood and take a look at the architecture. How are these things actually put together? You can basically think of a VLM as having three key components. First, you've got a vision encoder, something like a vision transformer, or VITE. Its only job is to look at an image and break it down into its most important features. Second, you have a large language model, an LLM, which is the brains of the text operation. And third, and this is the really clever bit, you have an alignment module. Think of it as the universal translator, the bridge that lets the vision part and the language part talk to each other. To make this real, let's look at how the InternVL 2 model gets trained. In phase 1, it's all about vision. The model just watches tons of raw video, and its goal is to learn the absolute fundamentals of seeing, things like patterns, motion, and how objects move and interact over time. Then comes phase 2. This is where the model starts to connect those visual patterns to actual meaning. The raw visual data it learned before is now paired up with other things, like text descriptions and even audio. This is where it learns that the pixels showing a dog's mouth moving not only match the words "a dog is barking," but also the actual sound of a bark. This is that critical alignment step. And in phase 3, it all comes together. Those newly aligned, meaningful features get plugged into a powerful LLM. And that's what unlocks all the amazing abilities. The power to have a real, open-ended conversation about what the model is seeing. Because now, finally, the vision and language parts are speaking the same internal language. All right, let's get down to brass tacks. This is the stuff that really matters for us developers. You've got this giant, powerful, pre-trained model. That's great, but how do you actually adapt it for what you need to do without needing a supercomputer and a massive budget? I mean,
That's the multi-million-dollar question, right? These models cost a fortune to train the first time around. So if you needed to recognize, I don't know, a specific defective part on your assembly line, do you have to start all over again from scratch? Well, the answer, thankfully, is a huge no.
The solution is this amazing family of techniques called parameter-efficient tuning, or PET for short. The old way, full fine-tuning, was a nightmare. It's super expensive, needs tons of data, and you could easily mess up the model. But PET methods are the complete opposite. They're lightweight, you freeze most of the giant model, and only train a tiny fraction of new parameters. This makes them way more resource-friendly and perfect for when you only have a little bit of data.
And this right here, this is your toolkit. These are some of the key techniques you can use. You've got methods like co-op and TPT, which are all about learning the perfect prompt to give the model. Then you have things like feature adapters and LoRa, which work by slotting in these tiny little trainable modules into the bigger model. The most important thing to remember is that all of these let you specialize a VLM for your job without ever having to touch the billions of parameters in its core.
And here's the bottom line. This is the crucial point. These PET techniques are what make this revolutionary technology accessible to all of us. You don't need the budget of a giant tech company to adapt and use these models anymore. This power is now genuinely in reach for developers and teams of all sizes.
Okay, let's start to land this plane. We'll wrap things up by summarizing the absolute must-know points, and then take a quick look at where this whole exciting field is heading.
So as a developer, what are the big things to take away from all this? First, VLMs are a huge leap, a real paradigm shift. Second, all their amazing ability comes from that massive pre-training step. Third, and this is the big one for us, you don't have to retrain them. You can adapt them using parameter-efficient tuning. And finally, techniques like adapters, LoRa, and prompt tuning, those are your keys to the kingdom.
Now, of course, it's not all solved problems. The field is still wrestling with some pretty big challenges. Scalability is always a thing. These models are getting bigger, not smaller. Continual learning is another tough one. How do you teach a model new tricks without it forgetting the old ones? And then there's the ongoing work of getting better data, building better tests, and of course tackling all the important ethical concerns around bias, safety, and fairness. But even with those challenges, you just can't lose sight of the incredible vision here. I think the source material really says it best. This is all about building machines that can understand and interact with the world in a way that's richer, more accurate, and just more human than we've ever been able to do before. And that power, that capability, is now truly in your hands as a developer. The models are out there, the tools are accessible, and the techniques are efficient enough to run. So really, there's only one question left to ask. What are you going to build with it?